So here's our general steps to compute beta. We compute the x value, x0, at the border of the acceptance rejection region using the inverse norm. So this is really mu0 plus our z alpha times s over square root of n. So this will be inverse norm in general. And then our area up here, our left area was 0.95, which was 1 minus 0.05. Well, here we're using alpha. So alpha is the right area for z alpha. 1 minus alpha is going to be the left area. And then your mean here is going to be mu0. And then your standard deviation is going to be s divided by square root of n. So that's the general case. Sketch your alternative distribution and compute beta, the area of the acceptance region, using normal CDF. So our beta here in general is going to be normal CDF. And then for this case, when we're looking at an upper tail test, it's going to be minus infinity. So we'll use minus 10,000. And then you go up to the x0. And then you use your alternative mean, mu sub a, and then still your s divided by root n. Now, if we were doing an alternative hypothesis that was a greater than, these would switch around. You'd be finding the right tail instead of the left. And then to finish up here, the power of a test here is the probability the test will correctly lead to rejecting the null hypothesis for a particular value of alpha or p proportion, if you're looking at type 2 errors for a proportion test. The power is equal to the quantity 1 minus beta for a particular alternative that's considered. And then just some properties here of beta. The power of a test. For a given n and alpha, the distance between mu0 and the alternative mean, mu a, increases. As that distance increases, beta decreases. Okay, that's what we saw as our beta decreased. For a given n, mu0 and mu a, as alpha decreases, beta increases. And then the power decreases. Power of the test decreases. So alpha and beta work in opposite directions. And then as n increases, beta decreases, and the power of the test increases. So if you want to decrease a type 2 error, you should increase your sample size. So increasing your sample size will decrease beta and increase the power of the test, 1 minus beta. So real quick here, the power of this last test here, if I asked you what's the power of that test, it would equal 1 minus beta, 1 minus 0.1147, which is 1 minus 0.1147, 0.8853.